This video entails the summary of Technology Trip 2, which is Tech 400. And in this section, we have two areas from the compulsory section, which is the computer part that explains about the supervisory control and data acquisition and industrial Internet of Things. And the other part is the building and construction part, which explains about cement manufacturing and Proctor compaction test. Let's start from SCADA. SCADA is a system that is used to monitor and control industrial processes and infrastructure such as the power plants, oil and gas pipelines, water treatment plants, and manufacturing facilities. SCADA allows operators to remotely monitor and control various aspects of process of a facility, providing real-time and data alerts for potential issues. The components of SCADA are the remote terminal units, the RTUs, which monitor and control various processes variables such as the temperature, humidity, pressure, and flow rate. The second one is the programmable logic controllers, the PLC, which controls the operation of equipment and machinery. The third one is the human-machine interface that allows operators to interact with the SCADA system, displaying real data alarms and controls. And lastly, the communication networks, which allows data to be transmitted and received, and it is achieved through the Ethernet and proprietary protocols. The second part of the computer section is the industrial Internet of Things. The IIoT refers to the integration of physical devices such as sensors and machines with internet-connected systems to improve industrial process and operations. It enables devices to communicate with each other and with centralized control systems to collect and analyze data in real time, allowing for improved efficiency, reduced downtime, improved safety, and improved productivity. Its components include the sensors, connectivities, analytics, cloud computing, and the control systems. We have the difference between the cloud computing and the edge computing. Cloud computing is developing the knowledge, while edge computing is knowledge in execution, in knowledge in action or execution of data. In building and construction section, we have the two areas, which is cement manufacturing and Proctor compaction test. Now let's start from the cement manufacturing. The raw materials in cement manufacturing are the limestone, which is extracted from quarries, and it contains the calcium carbonate. The next raw material is the clay or shell, containing silica, alumina, and calcium carbonate, and iron oxide. We have also sand, which contains silica, iron core, gypsum, used as a retarder to control setting time, in cement manufacturing and fly ash. The process of cement manufacturing starts from mining and crushing, whereby the raw materials such as clay, limestone are extracted from quarries or mines. Then they are crushed into smaller pieces using the crusher or hammer mills. The second process is blending and grinding. Crushed materials are mixed together in their correct proportions to form raw materials, which is then grounded into fine powder in a cement mill. The third procedure is preheating and pre-coloncing. The raw materials now are heated and pre-calcina to around 800 to 900 degrees Celsius. This process removes any moisture and converts the raw materials into a form that can be easily processed in the kiln. The fourth is clinker production, whereby the raw materials is fed into the rotary kiln, where it is heated at a temperature of around 1450 degrees Celsius to form clinker. The fifth is cooling. The clinker is then cooled, which uses water or air to reduce the temperature to around 100 degrees Celsius. After cooling, there is grinding. The cooled clinker is then ground into a fine powder with the addition of gypsum. And the last procedure is packing and shipping. The finished cement is then stored in silos and then packed into bags and transported in bulk by trains or trucks. The last part is the Proctor compaction test, which is a laboratory method of experimentals determining the optimum soil moisture content at which a given type of soil will become more dense and achieve its maximum dry density. The dry density of a soil depends on the amount of water the soil contains during compaction. It requires the following materials: the compaction rammer, the mold assembly, the trowel, brush, rubber mallet, wrench, straight edge tool, and spray bottle. It requires number 4, sieves, metal plan, coarse grain soil sample, moisture content, tin cans, and weighing scale. The procedure: the first one, you weigh the pan and mold assembly and note their empty weight. Sieve a soil sample using the number 4 sieves and collect about 6 to 7 pounds of the filtered soil. Place soil in pan and add water accordingly, varying on the wet to dry side of optimum water content. The fourth, you compact the specimen in 3 layers uniformly in the mold till full. Trim the top using straight edge. Weigh and record total mass. Collect specimen portion into the cans and weigh the wet and dry masses. And lastly, calculate dry unit weight and water content and plot the graph to obtain the compaction curve. Thank you. And that marks the end of the Tech 400 video.